Yeah, I'm on eHam at the moment. I've done some searches. I was trying to find a really old thread because years ago, James and I, we put up the huge megaloop, the big triangle, and worked some big DX on this triangle. And we happened to publish an article. I'm pretty sure it was on eHam. But we got all these people telling me, old guys, going, no, a big loop, okay, it's a cloud warmer. It's NVIS. Now, this thing was at 60 feet. We're on a 20-metre band, which is one wavelength off the ground. And it wasn't a cloud warmer there. And I've done pretty sure. I'll find a video or a screenshot of a mega loop on 20-metre band, right? At 5 degrees off the horizon, you'll find it's better, It's at 60 feet, 60 odd feet. It's, whereas a vertical would show you minus 5 dB gain. In the main, depending on the ground, we're getting better than that. I can't remember how much. I'll look it up in the post-production and do this. But anyway, I can't find that on the screen. But it reminded me that when I was a new ham, you trust people who know more than you. I had some weird problems. I remember putting some RG58 over the gutter, which was full of water, okay? And when I would transmit, the SWR would change. In other words, the impedance was changing. Now, looking back now, I was getting some capacitive effect between the coax and the water because the coax was probably really crappy. I didn't know any different. And I asked a few people. Rather than them saying, I don't know, what they were saying, they were guessing answers. You'll probably find, things like that. And it actually just confused me more. I mean, if they'd said, what coax is it? And I said, it's the cheapest I could buy, right? So it was probably something to do with that, all right? And sure enough, I've put, super high quality coax in water. Makes no effect at all. But do you trust your Elmer? Okay, so I'll give you another example. A 3/4 wave vertical has slightly more gain than a quarter wave. Now, when you look at the far field plots, in the main, what you'll see is that there's some very high elevation gain on a 3/4 wave. However, if you measure it and do, a couple of years of tests, you'll soon realise that low to the horizon, there's a little bit more gain. But if you talk to your Elmer, depending on who he is, all right, or who she is, they could very well grab the old myth out of the old book and tell you that a 3/4 wave isn't worth looking at. What else? There's the whole debate regarding elevated radials and ground-mounted radials. I've sold, 3,000 ground-mounted vertical systems. And if you look on eHam, everybody seems to have a great time about it. So I've also built, before DX Commander, a lot of elevated antennas with elevated radials. My God, what a bloody hassle that is. For what? For why? There was no difference, appreciable difference in gain. The only time, in my opinion, because the thing is, all Elmers have got a point of view, haven't we? Okay, even me, right? So you have to take everything with a little bit of a pinch of salt and go, oh, which bit of this is real? Get on with it and do it yourself, really. The difference between an elevated system and a ground system, you probably can't ever measure. All right, unless you're like over a wavelength above the ground, then you might find you'll get a bit more gain. 1.5 wavelengths, you do even better, which is why the big evolution I put up, which was at 16 metres, so 1.6 metres above the ground for the 10-metre band. Yeah, now I started to get 7 or 8 dB more gain. Because it's so high up. That's why VHF antennas work so blooming well when they're up on a pole on your chimney or your tower or something. They've only got 2 or 3 radials. Yeah, you don't need a lot of radials when they're that high up. So do you trust your Elmer of everything he's going to say? Because if he's just read a pile of books and not actually done it himself, he's not going to know. It's the same argument with coax versus balanced line. So when I came into this business as a hobbyist, I'd be on VHF and be talking to some old boy and they'd go, I remember them on. All telling me I had to invest in a doublet and a balanced tuner, because that was the best. For them, 30 years before this, so 50 years ago, when coax was probably quite new and expensive, use ladder line, 450 ohm, whatever else, outboard tuner, and they would make them themselves, all right? A lot of these guys were making their transceivers as well, weren't they? And they're not complicated things with SO239s on the back that we have. Now you can buy some reasonably high quality coax, and let's face it, on 20 metre band, 100-foot run, 20 metre band, the loss is negligible. So what we do now, instead of running like doublets, some random length or whatever, and have to tune the nuts off it with a tuner, we'll just cut it to length or put a fan dipole up. This coax works a dream. None of these knobs, switches or anything else. Don't get me wrong, I've had a doublet. I absolutely love it. But QSY is a pain in the ass, by the way. I'll meet you on 14.250 and you're on a 7.23. You go up there and you look up your chart. 47, 200, wind a knob and everything else. Hit the tune button, get the SWR right, and you've QSY'd. Unless you've got an auto tuner, that works fine. But the whole argument over balanced line and coax isn't so much these days. But if you've got an old Elmer, he might still be running a doublet, and he'll tell you it's the best thing to slice better, because that's what he knows, right? Because we've all got a view. Even I've got a view. So if I'm telling you something, you go, okay, well, that's Callum's idea. Let's have a look at the comments. See if other people are backing this up or they're arguing with him, all right? What's the other one? The impedance of a dipole. A lot of people who read the books will tell you the impedance of a dipole is, 72 ohms, 73 ohms or something. By the way, it varies depending on height above ground, all right? It ends up very, very high. It ends up at 70 ohms. It starts off really low. It goes up. Well, you're looking at a graph that way. It goes up to about 100 ohms and then comes back down. And if you want to adjust your impedance on a low to the ground dipole, just put it up a tiny bit or lift the legs a tiny bit. And you'll find that you'll come onto, there's a chart, all right, impedance of a dipole. Let's do it, actually. Impedance of a dipole. This one here. There we are. So let's, can we zoom that in a bit? Here we are, height above ground. So exactly a quarter wave. It says it's probably about 90 ohms. At nearly half a wave, it's down to 75. And then at somewhere between just over a half wavelength, it's about 60 ohms. So on 40 metre band, if you've got a dipole fairly low to the ground, quarter wave just under, down to there, eighth of a wave, so that's about 5 metres high. Yeah, that's right, 5 metres high. You'll have a perfect match to 50 ohms. Amazing, isn't it? All right? But what I'm trying to say is that people have a view about everything, sometimes depending on the books they've read, for instance. If you're challenging your Elmer, you go, have you done that? All right? Is that what? Because have you rehearsed it? All right? If you haven't rehearsed it, he's just plucking out of thin air. For instance, there's a problem with your car, and you go to the garage, and you say to the man, what do you think the problem is? He's going to go, well, it's probably that. He doesn't know yet because he hasn't stripped it down and had a look. All right? Everybody wants to give you a view. Everybody. If you will go on my Discord channel and you ask a question, there's a lot of people who love giving views just because they want to contribute. They feel they should. Not necessarily the right answer. It can send you off in all sorts of directions. So an Elmer who might be discussing coax with you, the last time he bought coax may have been 30 years ago. Okay, so he just remembers RG213 or RG58, and he'll be telling you that. He doesn't know that SSB Electronics have got SL7, that Messi and Poloni do Barryflex 10, and so on and so forth. So you have to do your own research. Don't rely 100% on one person explaining to you how it should work. I'm just giving you a bit of confidence. You've got the internet, you've got Wikipedia, you've got people like me doing ham radio channels. You can ask and poll around, because every problem you're going to have, it's probably unique, okay? It'll be unique. You put an inverted L up. Now, we all know that an inverted L on 80 metres normally gives you about 50 ohms, all right, depending on the ground. About. I put one up at the farm, and I was getting 112 ohms. Why is that? I had a unique situation. I had all this metal fencing. Yet other people have put an inverted L up with metal fencing around and about and haven't had a bloody problem at all. So what I'm saying is, a lot of the problems we have are unique to the planet, to where we are. That's the fun, isn't it, of RF, is exploring and trying to work out what's gone wrong. In the main, everything just works. But when we get a little problem and you ask around, sometimes nobody blooming knows. So by all means, ask your Elmer. But if he honestly doesn't know, and get it out of him. Get it out of him. Yeah? Do you know or not? No, I don't. Right, easy. Next video is coming up here. My rant for the day. Have a jolly good day. Thanks for tuning up. And I will see you next time. Bye for now.